Okay, good morning. This morning I'm going to talk to you about Freescale's automotive technology. I'm going to show you some demos in a few minutes as well. But I think for many of you in the audience, you'll have recognised that Freescale has been in the automotive industry for a significant amount of time. We've been around for about 30 years. We worked on some of the first microcontrollers for engine management and emissions control in the 1970s, and from that time we've gone on to develop solutions for safety and infotainment. So today, when most of us think about the cars we drive, we think of them as relatively efficient. And I think we think in those terms because we think of the cars that we've driven over the last 5 and 10 years. But if you actually look today, even the most efficient gasoline or diesel engine gets about 30% of the true energy value out of the fuel when it actually ignites it. In turn, as that goes through transmission systems and goes through tyres and aerodynamic drag, you actually end up getting about 15% of the energy from your fuel actually used. And that means that there's a lot of opportunities and a lot of advances that can allow that to change and improve. So, in terms of the different combustion systems and different engine systems that we use today, people talk a lot about electric and hybrid, but today the vast majority of the world drives internal combustion engine, and there's a lot of work going on to improve those. I'll talk a little bit about that, but also electric, plug-in hybrid and hybrid as well. One of the things I think was a major step forward this year was that for the first time ever, the Le Mans 24-hour endurance race was actually won by a diesel hybrid car, which is a major step forward. And what basically happened was that Audi were the car company who won, and they basically worked out that for an endurance race, one of the very important things you have to do is, well, first of all, you have to finish, which is very important. And secondly, if you can spend the least time possible in the pits and get the most time out in the track, you can also win. And so they went ahead and implemented that. The car could still do 200 miles an hour, but they managed to win the race based on that. And they also based it on the fact that one of the other reasons you need to have, or the things you need to have to win, is reliability. And they built a very high reliable diesel hybrid system. All of these systems can benefit from electronic assistance. And earlier this year we sampled our first new 5700 Cariva microcontroller product specifically for advanced engine control. And that product is a multi-core product. It has about 4 megabytes of flash and runs at 200 megahertz. And it's one of the first processors for engine management system where, in addition to just computing performance, we've also built in safety and security features. As many of these vehicles move to be drive-by-wire, it's become obvious that we have to start implementing some of the safety features that are in today's braking system. And you'll see used in Freescale terms a program called Safe Assure, which is our safety and functional safety program. In addition to that, we've got the Cariva family. We've also, in this generation, built in a security system, a security block to prevent hacking of code inside ECUs. And again, as many of these ECUs become controllers of drive-by-wire systems, it's important that the code that's running on the module is the code that's intended to be in. So one of the other areas we've been working on is advanced start-stop systems, which you'll have seen were introduced in Europe a few years ago, have now started to come into Asia and into the US market as well. And that's an innovative technology. One of the things you'll see in the early slide is that about 15% of fuel consumption in big cities is actually happens when you're sitting idling. And start-stop effectively makes it much more efficient. And what Freescale has is some very innovative power technology that allows an engine to be restarted in about 400 milliseconds. We've also been working in regenerative braking, which is a feature that is used predominantly on hybrid vehicles. And what that does is it turns the motor into a generator when you're in a braking mode. And that's been around for a couple of years, but it's been quite difficult to actually implement well. And so far, drivers haven't found the process enjoyable. And what we've been working with is some of those braking companies and how to make that a really enjoyable experience for the driver. But we haven't forgotten about gasoline engine management. And as I said, traditional gasoline engines are what the majority of the world drives on. And so we've been working on some advanced fuel injection systems with our partners. Direct injection itself can save about 15% fuel consumption in the vehicle. But we've also been working with them on cylinder deactivation technology. And what cylinder deactivation allows you to do is that on a large engine, a large V8 engine, it allows you to cut off the cylinders and run in a more efficient manner. This was originally tried about 20 years ago in mechanical systems and wasn't very successful. But nowadays, with the amount of electronic control we can provide through the latest processors, cylinder deactivation is now becoming common on large engines, but also it's now becoming common on simpler four-cylinder engines. And it's now possible to have a four-cylinder engine run as smoothly in a two-cylinder, high-efficiency mode as it would in its normal four-cylinder mode. So, as well as working in vehicle efficiency, we've also spent a lot of time working on safety systems and some advanced safety. So Greg talked earlier about the number of injuries that are related to traffic accidents in the Beijing area and globally. So we've all been used to airbags and anti-lock braking system, but how about if your car could actually look ahead and see an issue or recover an issue once you've caused an error? So we've been working with our partners on advanced driver assistance systems. These are things like radar systems, image recognition systems. Alex can hear us talk in the next few months about infrared systems that we're working on. And these type of systems allow you to start doing things like automatic braking on the vehicle. You'll have seen, I think about a year or two ago, Volvo introduced the City Save system, which is auto braking. But we're getting to the point where not only will we be able to do auto braking, we'll actually be able to do automatic steering as well. Freescale has announced its new family of radar sensors, the extrinsic 77 GHz family. We use for active cruise control and radar systems, and we combine those with some of our power architecture, core IQ devices, Kariba devices for that application. One of the other areas we're working on, and one of the areas you'll be actually able to see in the demonstrations outside, is our 360-degree camera system. What this is Freescale is part of the Open Alliance for Ethernet in-vehicle networking. And what we have outside is a demonstration of a set of Kariba microcontrollers networked together, and the image sticks together to give you a full 360-degree view around your vehicle. So important for parking, but also very important for advanced safety systems as we go forward. So I would encourage you to go and look at those systems. One of the other areas we've been working on is infotainment and instrument clusters, and we're going to show you a couple of demos here in a few minutes of those. I think as people remember, when the first navigation systems came out in cars, they were functional but a little bit clunky to use. And many of us, as we started to see the smartphones we used, or the iPads, or the tablet PCs, wanted to see some of that functionality in our cars. And that's one of the great benefits that Freescale brings to this market. We have a very successful product line called the i.X family in the consumer marketplace, and we've been able to adapt and use that in the automotive market space as well. And we're very pleased to say that GM OnStar are using Freescale's i.X 6 family for its next range of OnStar products. That's a telematic product used on a global basis. And it uses the rich graphics technology we have with i.X 6 and the advanced processing for the telematics functionality. In addition to the i.X family, earlier this year we announced the Vibrant family, and Dr. Kazaruni talked about that earlier in their use in the consumer market space. But we use the same architecture for automotive, and we use it to take all the benefits you get from an i.X processor with all the graphics processing, and we marry it with a microcontroller architecture, which makes it very simple to use in an instrument cluster or in a connected radio application. So as I said, we wanted to show you some demonstrations. And we've got a couple of instrument clusters that we've been working on. One of these is specifically very close to my heart. We can close in on this system. This is our MagnaV single chip instrument cluster. And the reason it's very close to my heart is we built this product. And as I said, it's a complete single chip instrument cluster. There are no other components. There's one microcontroller there, and it has all the features to drive the stepper motors you can see. There's the power supply, a sound generator, a real-time clock. And we designed it based upon inputs from Chinese customers. And then on top of that, we decided to design it. We would also design it here. We designed it in our Suzhou Design Center. So this is our Magna-V 16-bit instrument cluster. As I'm told, I can't pick it up. I wanted to show you something. If you can get the camera in the back of this, you see. One of the most important things in this is the complete instrument controller. It's this one single chip. So everything you can see in this instrument cluster is driven by that one IC. If you ever get a chance to look at the instrument clusters in your own car, you'll find normally there's about 5 or 6 different ICs behind the dashboard. And the instrument cluster beside this is a much more advanced upmarket instrument cluster. It's a full graphics instrument cluster with no gauges. And this one is based around Vibrid. And in fact, the system here only really uses a simple display controller built in. It's also got a full graphics controller and full microcontroller. And even for this demo, the only thing that's been used in this is actually the display controller. All of the processing power in the applications processor, the graphic processor, and the microcontroller is still there. And in fact, if you go onto Freescale's website, you're able to see a website that's got a connection that shows you how to do all the graphic control for this system. Okay, so that's the graphics. As I said, most of these demos will be in the tech lab. We also have the surround view system in the tech lab, so I would encourage you to all go and have a look at those demonstrations. Thank you very much for listening to me. Please enjoy the rest of FTF, and I think at this point I hand back over to Greg.